All right, so this is the 9-4 Common Core worksheets. We're doing examples 1 through 3. So taking a look at number 1, it says here, the table and the graph show how many words Morgan and Brian typed correctly on a typing test. For both students, the relationship between the words typed correctly and the time is linear. So we have all of Morgan's information in table format, and then we have Brian's information in the graph format. All right, so if you take a look at our questions, we're finding Morgan's unit rate and Brian's unit rate. And then the third question says, which student types more correct words per minute? Okay, so what we're looking for is how fast each one is typing. And we know that our time is in minutes, our Y represents the words. So when we find our slope, or what they're asking for in A and B is the unit rate, we're looking for the time versus how many words per minute. Okay, the unit rate, how fast they are each typing. Now for Morgan, we're given 5 different ordered pairs. You can use any 2 in order to find the unit rate. I always typically use the first 2 because they're the smaller numbers. Now remember, in table format, you have your x over y. Make sure when you find your slope, your unit rate, you're doing the change of y over change in x. So I'm going to do 30 minus 60, y1 minus y2, over 2 minus 4, x1 minus x2. So here I end up getting negative 30 over negative 2, which ends up giving me 15. Now what that represents is 15 words, 15 words, y, over time, which is x. So 15 words per minute. That's going to be the unit rate, 15 words per minute. All right, let's take a look at Brian. Now with Brian, he's in our graph format. Okay, now remember, for slope, you still need change in y over change in x. What we need is 2 points from the actual graph. Okay. All right, so what I'm going to look for are points that go through your grid lines here. So it looks like I can use looks like that's 120. So in 1 minute, he types 20 words a minute, which ends up being my unit rate, okay? But even still, I can pick a second point as well. I can pick 480, looks like it works too. But that ends up being my unit rate here is that 120. But just to prove it to you, change in y over change in x. So here I get negative 60 over negative 3, which ends up being 20, and we know that's words per minute. Okay. All right, so now comparing the 2, Morgan versus Brian here, which student types more correct words per minute? Well, that's going to be Brian, okay? He's typing faster at 20 words per minute. What's the difference? Well, he types 5 words per minute more than Morgan. And if you were to graph Morgan too, like her points, that's 220, 230. It would kind of look something like this if you graph these points onto that line there. All right, and that's actually what we're going to do in 1A. So sketch a graph of Morgan's test results on the same grid, and then compare them. How are they similar? How are they different? Well, they're similar in the fact that they are both linear, but how are they different? Notice that Brian's slope is greater. His is further away from 0, which makes it steeper. That's why Brian's graph looks like this, whereas Morgan's going to look like this. They both start at 0, but Morgan's graph is going to be less steep. 1B says here that Katie types 17 words a minute. Explain how a graph of Katie's test would compare. Well, if we just did that, she's going to be in between the 2, then her line would be something like this if we were to draw that. So she's in between Morgan and Brian. She's typing faster than Morgan, but yet slower than Brian. So her line's going to fall in between. And then 1C says here the equation of Jen's test results. Now we've got a 4th person here, okay? Her equation is this, 24x. So in this case, she's typing 24 words per minute. So she's faster than the rest of them. She's going to be a little bit steeper than Brian. And just kind of sketching, not very accurate. but she's going to be the steepest line yet. All right, let's take a look at example 2. So here we have Josh and Maggie buy MP3 files from different music download services. With both services, the monthly charge is a linear function to the number of songs downloaded. So Josh is going to one store, Maggie is going to another, but they're both linear. The cost at Josh's service is described by this equation. Y is equal to 0.5x plus 10, where y is your cost, and x is your, cost in dollars, and x is your number of songs. So the number of songs is causing the cost. Then we have Maggie, which they're giving me the information in a table format. So we have the number of songs 5, 10, 15, 20, 25, and then the cost for each one. So for part A, find the unit rate for each function. How much is the songs that Josh is downloading at his store? How much would it be for Maggie? Well, using the information from Josh from his equation, very simple. That in this case is going to be 50 cents per song. Okay, so the cost is 50 cents per song. Okay, in Maggie's case, since we're giving it to us in table format, here we're going to have to find our slope. So in this case here, our slope is going to be our change in y over our change in x. Remember, I can use any two. I'm just going to use the first two, y1 minus y2. So I've got my price over my number of songs. So simplifying, that ends up being 99 cents per song. So part B says, which function has the greater rate of change? And then what does that mean in the context? Well, the rate of change is your slope. So Maggie has the greater rate of change. Maggie's, wherever she's downloading her songs for, she's paying more per song. So part C now says that they want us to write an equation for Maggie's music service here. Okay, so we know that our M here, pen turned off, is 99 cents per song. Now, what I don't know and what the information is not giving us is the y-intercept. So remember, to find the y-intercept, I want to plug into this slope-intercept form. So I'm plugging in my slope is the 99. Now what we need is the x and the y, okay, your y and your x term, which I can just gather from up here. And I'm just going to use the first one because they're the smallest numbers. So if x is 5, if she downloaded 5 songs, she's going to pay $4.95. Well, now I know that it's 99 cents a song. So what I'm looking for is the initial charge. But 99 times 5 is $4.95. And $4.95 minus $4.95 gives your y-intercept as 0. So her equation in this case is just y is equal to 99x plus 0. Sorry, not plus x. I just meant to. So in this case, we can rewrite that as this. So part D says here, describe each service cost in words using the meanings of the slope and y-intercept. All right, so even though Josh pays only 50 cents a song, he has to pay that $10. So it's a $10 fee, a monthly fee. But Maggie has no monthly fee. So even though she's paying 99 cents for each song, in her case, she doesn't have to pay that big $10. So, maybe she only purchases 3 songs, then she should go with that plan. But Josh, in his case, even though he's paying 50 cents for each song, he has to pay that big $10. So if he gets a lot of songs, that's going to pay for itself. But if you're not getting so many, like in Maggie's case, then you don't need to. All right, so just wrote out the answer there. So Josh pays $10 a month fee, but pays only 50 cents per song. Maggie has no fee, but pays 99 cents a song. So part 2A says here, how much does it cost at each service to download 20 songs? So now if they're each paying, or if they're each downloading 20 songs, what would that cost then be? So you can take 20 and plug it into Josh's equation. So in this case, that's going to be y is equal to 50 cents times the 20 songs plus that $10 fee. That ends up costing Josh $20. But for Maggie, here you have y is equal to 99 cents times 20. That ends up being $19. $19.80. So for 20 songs with Josh, it would cost $20, but for Maggie, it would only cost $19.80. So 2B says here, you are trying to choose between the two music services. How could you decide which one's better for you? So if you plan to download less than 20 songs, that's greater than 20 songs, less than 20 songs, then you should go with Maggie's service. But maybe you really like music and you have a lot of songs that you want to download, then you should go with Josh's service. All right, let's take a look at example 3. This is actually going to kind of go back to section 7.4 that we did in the beginning of the school year, where we talked about systems of equations, two equations kind of put together. All right, so here in example 3, Jamal wants to buy a new game system that costs $200, but he only has $100 today, so he compares layaway plans at different stores. So a layaway is kind of like where there's an item that you want, but you might not have the money right away. So you can set up some payment plans where you can put some money down and then you keep making payments until you've paid it off, and then you can receive the item. So some people do this at Christmas time where there's things that they want but don't necessarily have the money for them. So he has two different plans that he's comparing to. So it says the plan at store A is shown on the graph. Okay, so in the graph we have the number of weeks and then the balance owed. Okay, so that's our line here. What we're starting at 0 weeks, he has the balance owed is 100, and then notice as the weeks go on, okay, as the weeks, oops, don't have anything selected here. As the weeks go on, what he owes goes less and less and less. Okay. All right, so it says now, so this was plan A in terms of the graph. Okay. Plan B store requires an initial payment of 60. So unlike the 100, an initial payment of 60 and then weekly payments of $20. So it says for part A, use the graph from the layaway plan at store A, which is on our graph, to write an equation in slope-intercept form. So remember, slope-intercept form, that's the y equals mx plus b. So in this case, just looking at our graph, our y-intercept is 100. When x is 0, y is 100. Now, what also that we need is our slope. So we can look for the rate of change. Change in y over change in x. You can pick another point, use slope formula. Or I'm looking at this point here. Let's see if we can get this from the graph. If I go down 20 and then go over, oops, 1, 2, I'm at that second point. So here I get my slope as -10, which represents, that's what we're deducting or paying each week. So here we can use that as y is equal to -10x plus the y-intercept, which is 100. Okay, so we're paying our bill or our balance. We're paying $10 every week from the initial balance that we owe, which is 100. All right, take a look at B. In B here, it says, use the description for the layaway store in Plan B. So Plan B is this one right here. To write an equation in slope-intercept form. Same thing, but unlike the graph, I just have all my information here. So it says the initial payment is 60. Now remember, if the initial payment is 60, remember that it cost us 200. So he paid 60, which means the balance that we have left over, which is what the y represents, balance owed, is the 140. So our y-intercept is in 60, but our y-intercept is 140. We have 140 left after we pay that $60. So that's going to be our y-intercept. And then our slope, and notice we're told that in the problem as well, our slope, change in y over our change in x, is going to be that -20, because it says here, we're making weekly payments of $20 until the balance is due. So that's going to be our equation for store B. So we have store A in the green, store B in the yellow. All right, so part C is we're sketching a graph for store B here. Okay, so store B, let me erase some of my markings here. Store B has the y-intercept of 140, so it's going to be up here. And then we can find our x-intercept too, which I think is going to be the easiest. So remember, to find the x-intercept, we're going to make y equal to 0 in our equation. So if y is 0, I'm going to add the 20x, so it would be 20x is equal to 140, divide by the 20, x ends up being 7. And our line for store B is going to look like this. So that means that in 7 weeks, our balance will be paid off. So part D says, how can you use a graph to tell which plan requires the greater down payment? Well, so the y-intercept is going to represent the down payment. So in our first store with Jamal, he required a down payment of 100. With our second store, they required a payment of 60. So part E says, how can you use the graphs to tell which plan requires the greater weekly payment? How can you use the equations? So looking at the graph, you're looking at which line is steeper. With the equations, you're looking at the slope. So the steeper line has the greater payment. That's going to be the second one. Notice that the payment wasn't as high, therefore you've got to make more payments as you go on. Versus the first equation, it's a less steep line, but notice the payment is drawn out. And then part F says here, which plan requires Jamal to pay for the gain system faster? So just like I was saying here, store B is going to require it to be paid faster in 7 weeks versus the first store, which is 10 weeks. So sometimes it all depends, what money you have, and then what payment goes with what. And here are just some of the answers typed. And then you are completing for today the practice numbers 1 through 8.